Hi, welcome to the video solution for Cambridge Physics Past Paper Solution. This is Cambridge O Level and Physics 50454 Paper 12, May June 2021. So remember, these O Level papers can also be used for the students who are doing IGCSE. And IGCSE students can use O-level paper, or O-level students can also use for further or more practice, and they can also use IGCSE 0625 paper for further practice. There is a very small difference, some small topics are differ, otherwise paper pattern, style of questions are exactly same. So it is a good idea that IGCSE student can also practice from O-level, or O-level can also practice from IGCSE, in my opinion, but it's your choice. Okay, so let's start. Question number 1. A student determine the circumference of a football. Which instrument gives a reading that is circumference of the football? Remember, a typical question of your MCQs, they ask you instrument or apparatus that you can use to do some measurement or some quantity. Here you need to find the circumference, which is in fact the length, and length of the football or circumference, and you need to find the instrument. So basically here, because you know that football is a spherical, so you cannot use meter rule, it is a meter stick. So I will give you a table in which we use, most common quantity and most common instrument. So mass we measure from top end balance and digital balance. Weight we can measure from spring balance and Newton meter. Length is measured from meter rule. Very small thickness of a coin, thickness of a paper, diameter of a wire, these kinds of stuff we use micrometer screw gauge. Current we use ampere meter, voltage we use voltmeter, and volume of a liquid we use measuring cylinder. Here we need to measure the length, but this length is not a straight length, this is a circumference, curved surface. So of course ruler is not a good idea, micrometer is for small, caliper is also for small, it's all about football. So measuring tape is the best instrument to measure the circumference. So option is D. A coin falls from rest through the air and eventually reaches a constant speed. There is a resultant force acting on the coin due to the two forces P and Q shown in the diagram. So these are the two forces acting when the coin is falling. P is acting upward, Q is acting downward. What happens to the force P and what happens to the resultant force before the coin reaches the terminal velocity or a constant speed? So remember, when object starts falling, so it starts experiencing a weight W, but a drag force acting upward. So what happens as object falls down? Weight remains the same, but drag force increases. This is a drag force, keeps increasing as object falls down. Now due to these two forces we have a resultant force. So this is the resultant force acting down, R, and this resultant force keeps decreasing as drag force keeps increasing. Weight remains the same, drag keeps increasing. This is drag. So the resultant force keeps decreasing until when D and W becomes equal, the resultant force becomes 0 and the object reaches at the terminal velocity. So what is happening? Force P is in fact a drag force, and as coin falls down, this P has to increase. So it cannot decrease. You can ignore A and B immediately. And C and D, both force P is increasing, so both are correct option. But what happened to the resultant force as object falling? As object falling, resultant force keeps decreasing and decreasing until the object reaches at a constant speed, where the resultant force 0. So resultant force keeps decreasing. So option is C. Question number 3. The diagram shows the forces acting on 4 identical solid blocks. Each arrow represents a force of 20 Newton. Which blocks are in equilibrium? So it's all about, it's not about rest state, it's about equilibrium. So there are 2 conditions of equilibrium. If you remember, the condition number 1 is sum of all forces must be 0. Sum of all forces must be 0. So forces acting left side must be equal to forces acting right side. Forces acting upward, forces acting downward must be same. And the second condition is there must not be a moment. So total momentum, sum of moment is 0. Sum of moments is 0. So clockwise moments must be equal to anti-clockwise moments. Now if you see particle P or the solid P, we have 2 forces acting. Let's call this F1 and F2. The thing is, F1 and F2 both are acting in opposite direction and their line of actions are same. So F1 and F2 both are cancelling. Number 1, they have a same magnitude. Number 2, line of action is same. So they are cancelling. So object neither will be producing moment, not rotating, not even unbalanced force. So P is in equilibrium. Q, we have opposite forces, but line of action of the force or both forces is not the same. So line of actions are not same. That means due to these forces we have a moment, and if you see, the moment will be clockwise. So Q will be rotating or spinning clockwise. So it is not an equilibrium. So Q and Q. So B, C, D are gone. So of course you don't need to see. So P and R only. But let's check R. Of course we have 2 forces. One acting upward, another force opposite direction acting down, and the line of action of the force. The line of action is important. Line of action of the forces is same. That means both forces are cancelling, and of course there is no rotation, there is no moment. R is also in equilibrium. So P in equilibrium, R in equilibrium. What about S? Yes, there is no rotation, there is no moment, but S has a net resultant force acting downward because both forces are acting downward. So there is a resultant force acting. So S will not be in equilibrium. So Q is not in equilibrium, S is not in equilibrium, P and R. So option is A. Question number 4. A student lists 3 changes that affect the stopping distance of a car. Number 1, increasing the braking force, increasing the friction between the tires and the road, increasing the speed of the car. Which change or changes increases the stopping distance? Of course, if you increase the braking force, then the stopping distance will be less. The car will be stopped quickly. Increasing the friction will cause car stops quickly, so less stopping distance. But if you increase the speed of the car, then stopping distance will increase, and you can visualize you are driving a car at the speed of 30 or you are driving the car with the speed of 60. Of course, speed with 30 will be come to rest quickly compared to the car moving at speed of 60. So if you increase the speed of the car, stopping distance is going to increase. So option is 3. The third option can only increase the stopping distance. Option is D. Question number 5. The diagram shows a satellite orbiting a planet at a steady speed. In which direction does the resultant force act on the satellite? Again, a typical question of your MCQs. They give you some particle moving in a circular path, and if some particle moving in a circular path, there has to be some resultant force acting on the particle, and that resultant force always acts towards the center. This is the resultant force, R. If particle comes here, then resultant force must act towards the center. So all the time this resultant force keeps acting towards the center, no matter where the position of the revolving object is. So option is A. In direction of A, the resultant force acting on the satellite. And in fact, if you recall, this resultant force is called centripetal force, the force needed to keep object in a circular path. Question number 6. The gravitational field strength in space is smaller than on the Earth's surface. A rocket is used to launch a satellite from Earth's surface into space. How are the mass and the weight of the satellite affect as the satellite moves away from the surface of the Earth and into space? How the mass and the weight changes as you move away, from the Earth. So remember, mass is the quantity that does not change no matter where you go. You go in the whole universe, everywhere the mass is same, but weight keeps changing place to place. So weight will be changing and mass is constant. So mass and weight, no, both are not affected. Mass is unaffected, but weight will be affected. Mass is decreased, no. Mass is increased, no. Mass is unaffected and weight will decrease. Of course, you are moving away from the Earth's surface. So maximum weight of the object is at the surface. This is weight where you have a maximum. As you keep moving away from the Earth, the weight keeps decreasing until you beyond the gravitational field of the Earth. Then you have a weightlessness or weight equal to 0. So weight will decrease. So option is D. Question number 7. Air is trapped in a cylinder by a piston. A piston is moved inward so that the volume of the air reduces. So apply the pressure, volume is reduced. This is the volume and this is the new volume. The density of the air in the syringe at the initial volume is this. What is the density of the air in the syringe at the final volume? So you need to find the density in the volume. Remember, the density D is equal to mass divided by volume. And clearly, mass is not changing because mass is number of particles in the piston or in the gas or in the cylinder, which are the same. So mass is the same. That means density depends upon the volume in this case. And if you recall, this is 1, 2, 3, 4. So you can say this, we have a 4 volume and this is only 1, 2. So volume becomes half. So this is the density, original density when you have a volume, initial volume. And the new density D dash will be mass over new volume, V dash. And this new volume is half of the previous volume. So D dash is equal to M divided by V dash. And V dash is half of V or V by 2. And this 2 goes up. And then 2 into M upon V. And N upon V is your initial density, which is 0.0012. That means new density will be double of the, so D dash will be double of the old density. Volume half, density double. So 2 times 0.0012, which is 0.0024. Option is C. Question number 8. Some forces are applied at a different distances from a pivot. Which diagram shows the force that produces the largest moment about the pivot? So we are giving pivot distance, we are giving forces. We can calculate moment produced in each option quickly. So, but remember, there is a a catch in each diagram. This length are in centimeter. Do not forget that, and these are in meter. So you must convert centimeter into meter, dividing by 100, so that you can find the moment. And moment is force times moment distance, F into D. This is the formula for moment. So you can find 90 divided by 100 into meters. So 0.9 times 50, whatever the number is coming. And then you can do B, 2 times, no need to convert, 2 times 30. And 0.5 times 80 and 3 times 18. Clearly, if you find the answers, the largest answer will be 60 Newton meter. So this is the largest moment, and these numbers you can find which will be less than 60. So option is B. The diagram shows a children's wooden play tower. This is a wooden play tower. Which change to the tower makes it more stable? Stability is all depends upon two things. Number one is the shape, and more importantly, center of gravity or center of mass, CG, or center of mass, CM. So if you make the tower narrower, of course narrow object cannot stand for longer, it will be unstable. So this is a wrong option. Making tower tall object is not stable, it will fall, so it is wrong. Lowering the center of mass, indeed, if you lower the center of mass, you have one object of some size and another object of same size, but the difference is this is the position of center of mass, this is the position of center of mass. Of course this is more stable compared to the first one. This is less stable. So center of gravity should be lower if you want some structure to be stable. So lowering the center of mass will make the structure stable. So option must be C. Raising the center of mass, of course, it is higher, so it is less stable. So option is C. Question number 10. Where on the graph is the limit of proportionality for an elastic solid? So limit of proportionality is the position where the graph stays the straight line. The point till the point, or where the point on the line or graph where graph remains a straight line, perfectly straight. So of course this is the limit of proportionality. So option is B. Because we need to find the point of limit of proportionality. 11. A weight of 2 Newton is hung from a spring. The extension produced is 6 meter. The 2 Newton weight is removed and 8 Newton weight is hung from the spring. The spring does not pass its limit of proportionality. What is the new extension? So remember, extension is proportional to the applied force or hanging weight or the deforming force. So it is proportional. If you double the force, extension will be double. If you halve the force, extension will be half. Now what is happening here? You see, before you had a 2 Newton force and you had extension of 6. Now 2 Newton force is replaced with 8 Newton. So what is happening? What are you doing? You are doing force as a 4 time. So force becomes 4 times. So extension must be 4 times. That means 6 times 4 is 24. So 24 will be your extension. Question number 12. An object is placed at the depth d below the surface of a liquid of density rho. On which expression does the pressure on the object depends? D plus P, D into rho. Sorry, it's not P, this is D into rho, density. D plus rho, D into rho, D divided by rho, rho divided by D. So it's a straightforward, easy question. You need to remember or recall the formula for the pressure at the depth D into the liquid. So you know that you have a liquid and you have some object here which is depth D from the surface. So pressure acting on this object P is equal to rho G and H. G is constant, which is a gravitational constant or gravitational field strength 10. So P is basically, if you ignore this G, then P depends on density into H. H is the depth. Remember, this is the depth H, or you can call it D. So rho into D. So density and depths are multiplied. Sometimes we use H, sometimes we use D. These are just symbol. So the general formula is rho GH. H is generally we use height, but here we use depth. In the question, they are using D for the depth. So you can write formula for pressure P is equal to rho G and D. If you ignore G, then rho into D, the product of density and the depth. So its option must be B, not A, C and D. The diagram shows the dimension of a box of mass M and the weight W at the rest on the table. What is the pressure on the table due to the box? Remember, a solid object placed on a horizontal surface, the pressure would be weight divided by area. Because weight is the force of the object applying on the horizontal surface. And area in this case, area of this flat surface. So P is equal to weight divided by Y into Z. This is the expression for the pressure, which is D. So mass, of course, you can ignore immediately. Do not waste your time. Yes, this is the volume. We do not use volume in a pressure. We use area. So Y into Z is the area. Option is D. Question number 14. Which graph shows the relationship between the pressure and the volume of a fixed mass of a gas at constant temperature? So this is basically Boyle's law. If you remember that pressure of a fixed mass of a gas at constant pressure is inversely proportional to the volume. An inversely relation graph is a curve. So pressure against volume, because of inverse proportional, we have a curving down. So of course, not a straight curve. Not a straight line, not this. B is the option. Question number 15. The work done by a force F on body is calculated by multiplying F by a quantity Q. So we find work by multiplying force with some quantity Q. What is Q? So remember, if you recall the formula for work, work is equal to force into distance. Second quantity is the distance in the direction of the force. This is important. This distance must be in the direction of the force. So Q is the distance traveled in the direction of the force. This must be our option. But let's see the other. B, the distance traveled perpendicular. No, if distance is perpendicular, then there will be no work is done. So work will be 0 if distance is perpendicular. The velocity of the direction, so there's nothing to do with the velocity. There's nothing to do with the velocity. Because if you multiply force with the velocity, it is not a work done. This is power. Okay. So option is A. A girl lifts an object of mass 1 kilogram from the floor and puts it on a ledge 2 meters above the floor. How much potential energy is gained by the object? So from the floor, an object of mass 1 kg is left and then put it there, and this height is 2 meters. How much energy? So the energy gained by the object is gravitational potential energy, which is E is equal to mgh. M is the mass, 1 kilogram. G is 10. Remember, G is 10 or G is 9.8, maybe a new syllabus. So into H. H is the height, 2. So 2 times 10, 20, and the 20 joule. So option must be D. A copper rod is heated at one end. Which statement describes how heat transfer occurs in the copper? So it is a solid object being heated, and heat is transferred from one end to another end. Remember, this is the conduction process in which we have a two process. So we have a rod, and these are the particles. Remember, these are lattice ion, positive ion. They vibrate or jiggling left or right, up and down, and hitting the neighboring atom. So due to vibration of the particle and collision with neighboring atom, heat is transferred. Along with the vibration of lattice ion, positive ion, there are free or conduction electrons that carry heat from hot end, and they move throughout, and then they transfer the heat to the colder end. So energetic copper molecule, so molecule do not move. So option A and B are immediately gone. Energetic free electron move from the cooler end to the hotter. No, heat is transferred from hot to cold. So this is wrong description. Energetic free electron move from hot to the cold end. So option is D. Question number 18. Which heat transfer process do not require a medium? So this is only radiation that do not require a medium or particle for transfer of heat. Remember, in conduction and convection, there are particles involved in the process of heat transfer. So if there are no particles, heat cannot be transferred. So radiation only. Option is C. The list shows 4 physical properties: mass, resistance, voltage, and volume. How many of these properties can be used to measure the temperature? If you want to measure the temperature, we can use resistance to measure the temperature, because as temperature increases, resistance changes. So we can use resistance. And of course, we can use measurement of voltage to measure the temperature. If you recall, we have a thermocouple. And then volume also can be used to measure the temperature in Boyle's law. So there are 3 quantities that we can use. Mass, measurement of mass, cannot help us to figure out how much temperature of the object is. So resistance, voltage, and volume, all these 3 can be used to measure the temperature, can be used to measure temperature. So there are 3 quantities. Question number 20. The diagram shows us clinical thermometer. So we have a diagram of thermometer. Which factor affects the sensitivity of the thermometer? It's all about sensitivity. So sensitivity is all about how big or how small the bore is. So this is all about bore. So the thickness of the bore defines the sensitivity. So the diameter of the bore affect the sensitivity. So option is B. Constriction, this thing is all about, it is stop the falling of the thread inside inside. There's nothing to do with the sensitivity of the constriction. Length of the glass tube, it's all about the range. And thickness of the glass tube, again, there's nothing to do with the sensitivity. Sensitivity all depends upon inner thickness of the inner bore or the capillary. So option is B. Thank you very much. I hope you understand. If you have any doubt, let me know in the comment section. I will try to give you an answer or clear your doubt as soon as possible. Have a nice time.